So these are two ESCs. Both were having a cover of simonk 30 amperes. Right one is from Nuvoton. It's based on 8051 microcontroller, and it has, I think, all the NFETs, most probably because NFETs is the new design that they're using for the ESC, using all the NFETs. So this one and this one are all NFETs. So this is 8051 from Nuvoton. Exact IC can be seen on my description. But one thing is that I was not able to find the code for this particular ESC. But either way, it's PWM based, so you have to give the PWM signal on these pins. Like one is the ground and one is the signal. Another thing is we don't have an open source code for this, so I think this will be for later one. Though the BSP for this particular chip is there, so one has to make it in C or maybe in assembly language. So this one is atmega8 microcontroller based 8-bit microcontroller, and now as you can see, I have attached some soldering wires, soldered some wires on these pins. So if you see here, this is the start point. If we count from 1 2 3 4 5 6 7 8 9 10 11, and then accordingly so on. So this one, so in order to flash a new firmware for it, we have an open source firmware, but it's these particular ESCs are really not being used right now. More the new ESCs like BLHeli and BLHeli-S and BLHeli-32 are being used. So BLHeli-S is also open source, which we can even modify the assembly code and then flash into it. But let's start with this. This is atmega based. Again, it has all the NFETs. So they have used an NFET design, which they say that all it's like 100% power efficiency is there. So I don't know, these are, I think, BEC BC. So and this is a 7805 voltage regulator. These are all the transistors that are connected to the atmega8, and then they are further connected to these resistors, and these resistors are then connected to these to switch these FETs. So again, now if you want to make flash the firmware in this, you have to identify the pins. Now to identify the pins, again, you have to start from this particular, there is a mark here, a circular mark. If you can see, I will bring it a little bit to this camera, and you can see. So if you refer to atmega8 datasheet, you will be able to find this particular package is TQFP. So TQFP packages pinouts can be found in their atmega8 based datasheet. So these are the pins. The fourth one is the reset. This pin is the reset. These three pins are not connected. If you see and pay attention on a new ESC. Another thing is, this one is the SCK, the clock. This is the MISO master in slave out. This one is master out slave in, and these two are just ground and VCC. Now once you connect these, which is a very a risky task, you could break the ESC. I was having some 3 to 4 ESC as I switched to BLHeli. We do these are outdated one, but still in the market, I think, yes, especially in Indian market. So if you are able to see, I have soldered the pins, and I was able to flash a new firmware, like modified firmware, like just a simple one-line modification, like increasing the number of initial music, not music exactly, the beeps, the startup tone. So I modified it and then compiled it using AVR dude, and then flashing this particular pin was the microcontroller was done by using KK multicopter. Okay, so another one is, instead of flashing, instead of soldering the pins here and maybe risking the ESC to short and even break the ESC, what I did was make a spider board. Now simple spider board is this one. So what you can do is just place the pins on the particular pins on the whatever the pins we need, like the reset one, the MOSI and MISO and clock, ground and VCC, and these are all connected to further to AVR ASP. This is the AVR ASP.
This is the repo TGY by simonk. If you know the model of your ESC, you can search for binaries in this link. These are the features as a list. These are some board pictures in this link for your reference. These are all the boards from different manufacturers and their pin configuration. These boards may have some other FET design or different analog design. Most of the docs are in this only. This is an Excel sheet maintained for all the models and their FET/microcontroller pin configuration. There are some other very useful links mentioned at the start of the Excel sheet. Check them out. Let's go over the links at the start of this Excel sheet. This link in the Excel sheet got to a forum where you can see what other people have done and issues faced for different ESCs. How they connected the programming pins. People soldered wires or made touch-type connector to program the ESC. Some ESCs had pads for the programming pins. This is the atmega8 microcontroller pin diagram. You are able to see the pins that concerns us as highlighted in circles. Now got the Turnigy repository and go to the build from source heading. It is written make all to make all the variants in this repository. Please read the important information in the repository. Now we go to the shell and do a make all command. Once done, it will look like this. Search on Google for KK Multicopter and you will see this website. For Linux, we will download the first one. A zip will be downloaded. Now extract that zip file. Open the extracted directory in the shell. There will be a dodge file as kkmulticopter_64 dodge. Maybe you have to do a chmod to make it executable. Once done, you will run the shell script. Run this file. The KK Multicopter will start the GUI.
Like check the continuity by putting one of the using the multimeter, checking the continuity by putting one probe here and then again another probe, the other probe here, to check the continuity of these, the traces, the PCB traces. Now also another one is you have to check all these NFETs. If these are NFETs, that will be more easy to identify which is to use. The default
TGY ternary.hex that is made after compiling and after assembling the whole make all from that particular repository from simonk. And so this is, you will be able to find it. There are number of links that they have provided and it has number of ESCs that they have documented in order to get which ESC, which firmware is for which ESC. So you have to do a bit of research. This one was direct one. I just have to compile it and then flash it using the KK Multicopter. It was tgy.hex. It has a default from if you want to also identify, you have to trace back the traces. like that. So there is one more thing. I don't know. So I ripped everything apart from one of the ESCs that I breaked, and from what I understood was I followed these traces, and accordingly I mapped it to the inc file .inc file in include file for assembly in that particular repository, and I was able to what do you say, to verify that this one was the tgy.inc was the already the default one. So it didn't take much of time. I even ripped out this particular FET in order to see what's inside, but wasn't able to figure out what was it. It needs some more delicate handling, I guess. Yes. So this is the one. Now, in order to now we can just go back and try to flash one after changing maybe a line or something. It's a whole assembly code, so you have to block by block understand it in order to understand what exactly is going on the whole process, and that's because it's an outdated one, it's not worth that much of time. We will do that in BLLES to verify that this one was the tgy.inc was the already the default one. So it didn't take much of time. I even ripped out this particular FET in order to see what's inside, but wasn't able to figure out what was it. It needs some more delicate handling, I guess. Yes. So this is the one. Now, in order to now we can just go back and try to flash one after changing maybe a line or something. It's a whole assembly code, so you have to block by block understand it in order to understand what exactly is going on the whole process, and that's because it's an outdated one, it's not worth that much of time.
This is a setup I made for powering up 4 ESCs. This is the battery. This is 4-way power distribution using thick solder and 1 mm multi-strand copper wire. Below is a makeshift spider board where I put in the ESC and access the programming pins of an atmega8 microcontroller based ESCs. These spider board probes are connected to the AVRASP pins. These pins are MISO, MOSI, SCK and ground. I didn't connect the VCC wire. It was giving me issues. You just have to put in the USB. Otherwise, you can select in drop-down list in KK Multicopter. This is Tay Shell. We will clone the repo. Once cloned, we can go inside the repo and check for the files. Search for gy.hex and open it. Search for main semicolon in the Vim editor. Once found, search for a beep in the main routine. Here is the beep routine. The underscore F1, F2, F3 are the frequencies in which the tone is to be played. First, let's check if we are doing it right by comparing it with my previous trails. Now let's copy-paste the startup beep tone 2 more times. Now we will copy it and paste it 2 more times. Done. And now type in make all to compile or assemble them to hex format. There is no error and other anomalies. Success will look like this. You will get a tgy.hex file. Now open the KK Multicopter using the shell script. programmer will be automatically sparse. Choose the tgy.hex in the file system. There is a mini video on the top right where you can see the programming and success. We switch it off and then switch it on. We hear 3 tones instead of 1. If there is no error and other anomalies, success will look like this.